For this lesson, I want to discuss graphing functions and specifically using a new notation called function notation. So that is this portion here. This is read y is equal to f of x. So we've been using y, but it's equivalent to write this symbol here as well. So let's check out example 1 where this is f of x is equal to 2x plus 1. This is no different than writing y is equal to 2x plus 1. It means the same thing if you replace y with the symbol f of x. So to compare it to the previous lesson, it really works the same way where to graph this, you can create a table of values. You choose things that you'd like for x, like -3, -2, -1, 0, 1, 2, and 3. And then you find their corresponding y values. So let's try it for, let's just say x equals -3. The old way of doing it was to take y, place -3 into x, and simplify this. So that's 2 times -3 is -6, plus 1 is equal to -5. And that's what goes here. Using this new notation, f of x is equal to 2x plus 1, we do almost the exact same thing. What is different is you write f of -3 on the left, but you still write 2 times -3 plus 1 on the right. So this symbol that appears here, we would say f of -3. It's indicating that you're putting -3 in place of x. So this symbol stays as is, but we still simplify the right in the same way, where you get -6 plus 1, and then I would write f of -3 is equal to -5. So there's no difference between writing the point -3, -5, or using the notation f of -3 is equal to -5. Those two things mean exactly the same thing. So anyway, at -3, we will place -5. So we have this point here. And if we want to get this entire equation, we would just get a few more y values for the corresponding x values. But instead of filling it out here, I just want to get one other point and draw the line that goes between the two that we have on our graph. So I'm going to choose, I already used x equals -3. Let's use x is equal to 2, but we'll take this new approach of putting it in place of this x and then simplifying the other side. So to figure out, well, what is happening at x is equal to 2, I'll go to my function. I will put 2 in place of x, which means it goes in place of every single x, and then I simply reduce the right side. So 2 times 2 is 4, and then 4 plus 1 is 5. This means if x is 2, y is equal to 5. So I will now plot this point. So that is at 2, we get +5. If you were to complete the entire table of values, you would see that this is going to be a linear equation going through these points. So I'll simply just draw the line going between these two things. And that's it. It's what we did in the previous lesson. It's just using a brand new notation for it. For this next example, same idea as the previous one. I would like to sketch a graph of this function. So you're only allowed to use f of x if you're certain you do have a function, but I think that'll be clear once we get the equation. So let's see. I only want to use function notation this time instead of creating a table of values. So here's what I'm going to do. I will figure out f of -3 and then write it as a point and then plot it. So let's see. This is asking what is happening at x is equal to -3. If you put -3 into the absolute value, it changes it to +3. This is f of -3 is equal to +3. Said another way, this is the point -3, 3. So let's plot that. At -3, you get 3. Okay, moving along. let's see, f of -2, I think I see what's going to happen here, but this is the absolute value of -2, which changes it to +2. That is, f of -2 is the same thing as y is equal to 2, or -2 comma 2. So let's see, at -2 we get 2. For f of -1, that's the absolute value of -1, which is equal to 1. So f of -1 is 1. That's the point -1 comma 1. Same thing. I think if I get one more, f of 0, that's the absolute value of 0, which is equal to 0. F of 0 is 0. It's the same thing as the point 0 comma 0, which is located right here. So here we go. I have 4 points on my graph. Now, if I check this or I compare it to, let's say, well, what's f of +2? What's that equal to? It's the absolute value of 2, but the absolute value of 2 is just 2. So this is the point 2 comma 2. So if I put that on the graph at 2, you get 2. And once I make that observation, I can look at, well, what about f of +1 as opposed to f of -1? I know that answer is going to be 1, or that's just the point 1 comma 1. So I'll put that over here. In fact, f of 3 should be 3, f of 4 is 4, f of 5 is 5. If you compare it to negative values, f of -4 is +4, f of -5 is +5. I think we have more than enough to say the graph is the line that goes through the corresponding points. So we get this here. This is my graph. So I didn't use a table of values, but we are in some sense doing the exact same thing. You choose an x, you put it into the function, and you figure out the corresponding y. And maybe just a couple of other things. The domain of this function is all real numbers, but the range is from 0 to infinity. And for example 3, I mentioned that I was using f of x, but technically you can use any letter that you would like to, provided that you're not saying x again, so there's no confusion. So for this function, you can use the letter g. There's absolutely nothing wrong with that. It's however you decide to label your equation, but I want to take the same approach where I'm going to sketch a graph of this function, but just using the function notation itself. So I'm going to choose some numbers, and since we have a square root, I think I want to choose numbers that are perfect squares. So I'll start with, what is g of 0? That is the square root of 0, and the square root of 0 is 0. Said another way, g of 0 is 0, which is this point right here, 0 comma 0. I think another useful point to look at would be, well, what happens at 1? Well, g of 1 is the square root of 1, and the square root of 1 is 1. So g of 1 is 1 is equivalent to the point 1 comma 1. So far, nothing crazy is happening here. If you try 2, g of 2 is the square root of 2, but on a calculator, if you compute this, it's a decimal. Nothing wrong with that, but it just might not be easy to sketch on the graph paper here. So I want to now move to a different value. Nothing wrong with this, but let's get something that's a perfect square, like 4. The square root of 4 is 2. So since g of 4 is 2, that's the point 4 comma 2. So that's here. Another good one would be, well, I know the square root of 9 is going to be perfect. So if we take the square root of 9, that gives us 3. This means since g of 9 is 3, we have the point 9 comma 3, and that is located over here. The graph that connects these points is not a line, but it kind of curves a little bit, and it starts increasing slower and slower as we go towards positive infinity. If you want to check out some negative values, I think something's going to go wrong here. So like if you did g of -1, well, that's the square root of -1, but this gives me an error on my calculator. And that's a good way to notice that, okay, the domain is not going to be all real numbers here. At -1, you tried putting that number into your equation and it gave you an error message. That means there's no y value that you can plot. So this is a pretty decent sketch of the graph. From here, I think we can reason out, well, the domain is going to be everything from 0 to infinity, because you can't put negative numbers into the square root. Also, the range of this function is going to be from 0 to infinity as well. Anytime you take the square root of a number, it always gives you a positive number back. The exception being, well, if you put in 0, that gives you 0 in return. So I have a sketch of my function. I can determine its domain and range, and that is it for this example.